In this lecture, we are going to discuss about the basic type of modulation, that is amplitude modulation. And the process of amplitude modulation is that varying the amplitude of the carrier signal with respect to the instantaneous value of the message signal. Let's suppose if you have a message signal is something like that, m of t is your message signal, and the message signal is always a baseband signal, and the amplitude of the message signal is AM, and this is the sinusoidal that is varying with respect to t. And the carrier signal is written by C of t is equal to AC cos omega CT, and the amplitude of the carrier signal is AC, and you can see that amplitude of the carrier signal is deterministic, and the frequency of the carrier signal is deterministic. The second thing is that you can note that the frequency of the carrier signal is much bigger than the frequency of the message signal. If you wanna see the amplitude modulated signal of these two signals, like multiplying mt with the cos t, and then you can see that the modulated signal phi of am looks like this. That you can see that the amplitude of the carrier signal is going to vary with respect to the message signal. So, like you can see that the message amplitude of the message signal is added up in the amplitude of the carrier signal. So we can write like this: m of t plus AC and cos omega ct. So if you take the constant AC, so you can write the same signal in this format: AC cos omega ct 1 plus 1 over AC m of t, and 1 over a is 1 over AC is equals to, you can write 1 over AC equals to Ka, that is the sensitivity of the device, and this signal is like something like this: cos omega ct, so 1 plus Ka, and then mt, that is your modulated signal. So where the amplitude of the modulated signal is going to vary with respect to the message signal. So you can rewrite the same signal in this format, like cos omega ct AC, so AC cos omega ct and mt cos omega ct. So in this signal you can see that one portion is your carrier, so like this one is your carrier signal, and the second one is the sideband where you are transmitting the information. So if you want to see the frequency content of that message, so for that we have already discussed in our previous video that Fourier transform is usually used to see the frequency contents of a message signal. So if you want to write the if you want to take the Fourier transform of your carrier signal, so that is the Fourier transform of the carrier signal, like AC pi delta omega minus omega c plus delta omega plus omega c, and you can write this cos omega ct in this format as well: e raised to power j omega ct plus e raised to power minus j omega ct divided by 2, and then multiplied by the message signal. So if you took the Fourier transform of that message signal, you can write in this format like half of m. So the m is the Fourier transform of small m. So this is the capital M omega minus omega c plus capital M omega plus omega c. So the overall modulated signal, the Fourier transform of the overall modulated signal is the result of these two equations. So like this is equation number 2, and then you can add up equation 1 and equation 2, and then you will end up with the modulated signal. So in the signal you can see both two pulses, so that is pulse 1 and that is pulse 2. In pulse 1 you are seeing the centered the carrier frequency omega c, and on the both sides, one is the lower sideband and the other one is the upper sideband. So this is the negative, so minus omega c plus omega m. So omega m is the frequency of the message signal, and omega c is the frequency of the carrier signal. So minus omega c minus omega m, and then minus omega c plus omega m. So that will be lower sideband, and this will be the upper sideband. Similarly here, so omega c, and then this lower sideband will be omega c minus omega m, and then the upper sideband is omega c plus omega m. So that was the basic amplitude modulation. So if you wanna take an example of single tone modulated signal. So single tone means that a signal which has a single frequency. So if you can say that the m of t is equals to am cos omega ct, then we can represent the amplitude modulated signal in this format as well, like that is equals to am cos omega mt plus ac and then cos omega ct. So which can be equals to, if you further like take the common of AC cos omega ct, so that is 1 plus am or AC cos omega mt. For this one am over AC, so that is the modulation index. So this one is the modulation index, and you can write is as a mu. So let it modulation index as it is here. We will further explain what is the modulation index and what's its impact on the modulation or the modulation process. So in our next lecture we will discuss it in more detail. So like if we further open that circuit, we can even write this as like this: AC cos omega ct plus, and then so if you multiply this with that one, so the other one is am cos omega mt into AC cos omega ct. Like you can write in this format as well. So AC cos omega ct plus like if you wanna write this like this, so that is mu AC and then cos omega ct as well. So like if you wanna represent this in this format, so like AC cos omega ct multiplied that one, so this one is basically, if you first write this like this, cos omega ct and then 1 plus mu cos omega mt, and then you can write in this format like AC cos omega ct plus mu AC cos omega mt and then cos omega ct. And we know that we can write this as like this: AC cos omega ct plus mu AC, if you divide 2 and then multiplied by 2, cos omega mt into cos omega ct. So this is a trigonometric term, so that is 2 cos alpha cos beta, so that is equals to cos alpha plus beta plus cos alpha minus beta. So using the same formula, we can open these equations, that is AC cos omega ct plus mu AC divided by 2, and then you can write cos omega c plus omega m plus cos omega c minus omega m. So you can see, so this one is basically so that one is basically your carrier. So you are transmitting the carrier as well as sidebands. So where the information is being transmitted, like most of the all your information is transmitted in this equation, and you are wasting your power with the carrier, that your carrier is also transmitting. So if you want to write in terms of the waveform like this, so you can see that you have a carrier and then on the both side of the carrier you have both frequencies like omega c. So if this is carrier, so it means that this will be omega c minus omega m, and this will be omega c plus omega m. And the amplitude of these two is mu AC by 2, whereas the amplitude of that is AC. The amplitude of that is AC. So you can write in this format, but the main thing is that you are transmitting your modulator signal. So like AM modulator signal, basically the combination of the carrier signal. So this is a full form of the modulator signal, which is the combination of the carrier signal plus sidebands. So you are transmitting the information. So here you are transmitting no information. So here you are transmitting the information. Only this is the message that is required to be transmitted. But this is basically wasting your power. So that's all. Today in this lecture we are just going to explain what is the amplitude modulation and how can we mathematically and represent that amplitude modulation, and what are the waveforms of that amplitude modulation, and what are the frequencies are different frequencies, and what is the waveform of that one, and what are the carrier and what is the sidebands in the amplitude modulations. So I hope that you understand the basic procedure of amplitude modulation, and we will of course explain what is the modulation index in our next video. So if you like this video, so you are most welcome, and if you have any question or recommendation, please write the question in the comment box, and keep in contact so that you can understand the further lecture. Thank you for watching our video.